today's video, we are going to explore the concept of limiting reactants and understand how they influence the calculations we perform when determining the mass of a product formed during a chemical reaction. To understand what a limiting reactant is, let us picture a beaker that contains hydrochloric acid and into which we drop some solid calcium carbonate. As the hydrochloric acid reacts with a calcium carbonate, a chemical reaction takes place producing calcium chloride, water, and carbon dioxide gas. You will be able to observe that a reaction is occurring because the solid calcium carbonate will gradually dissolve and bubbles will form and rise to the surface, which represent the carbon dioxide gas being released. However, after some time, the calcium carbonate will disappear completely, and the fizzing or bubbling caused by the carbon dioxide will decrease and eventually stop altogether. This cessation of the reaction indicates that one of the reactants has been completely consumed and is no longer available to continue the reaction. If we observe that the solid calcium carbonate has completely vanished while the hydrochloric acid remains, then we can conclude that the calcium carbonate has been fully used up and is therefore known as the limiting reactant because it determines and limits how much product can be formed. In contrast, the hydrochloric acid that remains unreacted is said to be in excess. This distinction is critical because the amount of product produced in a chemical reaction depends solely on the amount of limiting reactant available at the start of the reaction. For instance, if we added more calcium carbonate to the beaker, we would see more fizzing occur because more product would be formed, but once again the fizzing would eventually cease as the calcium carbonate gets used up. However, if instead we added more hydrochloric acid, it would make no difference because there would be no calcium carbonate left for it to react with, so no additional product would be made. Now, when it comes to solving calculations, sometimes the question will explicitly state that one of the reactants is in excess, but in other situations, it may only be implied. For example, consider the question that asks us to calculate the mass of sodium oxide that is produced when 115 grams of sodium are burned in air. The term burning in air refers to a combustion reaction, which essentially means that the sodium is reacting with oxygen. Since air contains a large amount of oxygen, we can reasonably assume that oxygen is in excess in this case, which means that the sodium must be the limiting reactant. The very first step in solving a question like this is to write down the correct chemical equation and then balance it properly. If you are not yet confident in balancing equations, there is a helpful video linked in the description that goes over that process. Since our goal is to find the mass of sodium oxide formed, we must begin by calculating the number of moles of sodium oxide that can be produced. In order to do that, we first need to work out the number of moles of sodium that we started with. To do this, we use the well-known formula that moles equals mass divided by m(r), the relative atomic mass. So we take the mass of sodium, which is 115 grams, and divide it by its relative atomic mass, which is 23. This gives us 5 moles of sodium. Next, we look at our balanced chemical equation to find the molar ratio between sodium and sodium oxide. The balanced equation shows a ratio of 4 moles of sodium to 2 moles of sodium oxide, which simplifies to a 2-to-1 ratio. Therefore, if we use 5 moles of sodium, then according to the ratio we will produce 2.5 moles of sodium oxide. Now, the final step is to calculate the mass of the sodium oxide that is produced. To do that, we rearrange our formula to mass equals moles multiplied by mR. We already know that the number of moles is 2.5, so now we need the mR of sodium oxide, which has the chemical formula Na2O. This includes 2 sodium atoms, so we take 2 times 23 and 1 oxygen atom, which is 16, giving us a total mR of 62. We then multiply 2.5 by 62, which gives us 155 grams. Therefore, the mass of sodium oxide that will be produced in this reaction is 155 grams. That brings us to the end of this video. We hope that you found this explanation helpful in understanding limiting reactants and how they impact chemical reaction calculations, particularly in determining the mass of products formed. We'll see you next time for more chemistry concepts.